Okay, good morning, guys. Let's start with page 2 of the lecture 2 notes. We completed page 1, right? Entirely. Zoom in just a little more. So it says, let C, TK be a sequence of contributions, i.e. the contribution at time TK, like this. So time TK, and the contribution is C, T of K. Positive contributions are deposits. So everything positive will be a deposit, and everything negative will be a withdrawal, as usual. Negative contributions represent withdrawals. The sequence of investments is governed by some amount or accumulation function A of t. In other words, it's not always compound interest, is what it's saying, right? It could be any A of t. The sequence of investments is liquidated at time t and produces a balance of B. So let us draw another timeline. 0. At some time t, all these contributions are liquidated and you get B. Produces a balance of B. Suppose we pick an arbitrary time tau at which to value all our contributions. So any time 3, time 5, time 0, whatever is most convenient for us. So let there be a time tau where we will be valuing our contributions. I will explain in a minute. So it says, suppose we pick an arbitrary time tau. The value of all contributions at tau is the value of the liquidated amount at tau. So I'm talking about the time tau equation of value. So if I have a contribution here, I would have to bring this contribution back by dividing by A of t, K, just like we normally do, and then forecasting to time tau by multiplying by A of tau. Just like you did on your homework, on your written assignment, right? That's what I'm talking about. If it's compound interest, you wouldn't have to do this. You can just go from here to here. We know that. But we're not talking about necessarily compound interest. We're talking about some strange A of t. So you would first have to bring it back to 0 and then increase and then forecast it to time tau. That is what is going on by dividing by A of tk and multiplying by A of tau. And you can see that that is what is being done here. C tk divided by A of tk times A of tau. Are you understanding me? I want to lower the volume on this because it's echoing. Okay, give me 1 second. Okay. Let's do the same thing for B. Let's bring this back. So divide.
Could you go up a little?
Oh, thanks. Divide by A of t. In other words, V of t, right? V of t is 1 over A of t. And then here's time tau. So forecast to time tau, multiply by A of tau. That's what's going on here. Here there's no summation because there's only one b. So divide that b by a of t and forecast to time tau by multiplying by a of tau. Is there any question? And tau can be any value. Tau can be 0, tau can be 3, tau can be 10. It doesn't matter. Whatever is the most convenient for us. So if it's compound interest we're talking about, if compound interest, then it would be C TK V to the TK summation, because this is all the different contributions on the left side, equals B V to the T. This would be the time tau equals 0 equation of value. Does this make sense to you? Meaning, if I choose to bring everything to 0, period, then it would just be all of these C's brought back equals B brought back. How do you bring B back? You multiply by V to the T power. Anybody lost? Go ahead.
So if I make an investment for 5 years and I do a deposit every year, so I have to discount that value every year to find out.
So whatever you put in at time 1, you discount by 1 year.
And then I do the same thing.
So let's say you put 100 at time 1, you would say 100 V to the 1. If you're bringing it back to 0, if your tau is 0, you decide what your tau is.
No, in the case tau is 0.
Then it would be 100 V to the first power plus, let's say at time 2 you put in 200, 200 V to the second power, like that. That's all. Any question? It says, notice that A of 0 equals 1, V of t equals 1 over A of t. So if we replace tau with 0, we get the time 0 equation of value, which is just the present value of the entire cash flow, which is what I have done here. Then it says, to value any cash flow, you need to choose a time tau at random or whatever is convenient for you, and discount each contribution on the timeline to that common point so you can compare. If you solve for some unknown using the time tau equation of value, your results are independent of tau. I'm going to show you by the next example by doing a time 0 equation of value and by doing a time 1 equation of value, and your answer will be exactly the same. So let's look at the example. It says examples similar to 2.3.5 from the text. A loan of $2,000 is governed by compound interest at 6%, annual effective interest rate 6%. It is repaid by a payment of $600 at the end of time 1 and a payment of P at the end of year 3. So let's draw a timeline. A loan of $2,000. So let's look at this from the perspective of the lender, okay? From the perspective of the lender. So the lender is shelling out $2,000 at time 0. It is repaid by a payment of $600 at the end of year 1. So let's go to time 1. And the guy is getting back his $600, right? The guy who loaned out the $2,000 is getting a deposit of $600 because I'm paying him back, so it's positive. And a payment of P at the end of year 3. Calculate P. So first let's do a time 0 equation of value. Time 0 equation of value. Tau is 0. So bring everything back to 0. Minus 2,000 plus 600 v to the 1 plus p v to the 3 equals 0. Agree? Brought everything back to time 0 by discounting. So let's clean this up. Minus 2,000 plus 600 over 1 plus I, 1.06, plus p over 1.06 cubed equals 0. And let's solve this. Can we solve it right now? Pull your calculators out, guys. I have minus 2,000 plus 600 divided by 1.06 minus 1433.96 equals p over 1.06 cubed. Therefore, p equals, let's multiply by 1.06 to the third power. 1707.87. Yeah.
Is that positive?
Well, this one became negative when it came over, so this is positive, yes. Thank you. Yeah, when I brought this term over, it's negative. They're both negative, so p is positive. Now let's do the same thing with a time 1 equation of value. If tau equals 1, what would happen? We claim that the answer would be the same regardless of the tau that we choose, right? Yes, question?
I have a question. So the interest amount, how much will be the interest amount? Will it be p minus plus 600 or no?
The interest amount where? You can bring all the money that you've paid to time 3 and then subtract 2,000, and that would give you the total amount of interest paid. So 600, 1 plus I square plus p, that would be the total amount paid, and you came away with $2,000, so the difference would be the total interest paid. Make sense? Okay, so let's now find the time 1 equals tau equation of value. So once you get used to doing this, you will automatically pick the tau that is most convenient for you when the problems get a little crazier. Right now it's as simple as it can be. Are you with me? Let's do the time 1 equation of value. So bring everything to time 1. What's the value of minus 2,000 at time 1? Minus 2,000, 1 plus I, plus 600. 600 is already sitting at time 1, so I don't have to do anything to that. Plus p over 1 plus I square equals 0. Does this make sense? And then clean it up. So minus 2,000 times 1.06 plus 600 equals negative p over 1.06 square. So minus 2,000 times 1.06 plus 600, 1520 negative, negative 1520 times 1.06 square equals minus p times 1.06 square. 1707.87. No difference at all. So your choice of tau is independent of the answer, right? Yeah.
Where'd you get the 1 plus I
multiply by 2,000 under your tau equation of value?
Here?
Yeah.
So this 2,000 is 2,000 at time 0. What is its value at time 1? I am bringing everything to time 1 in this one. In this one, I was bringing everything to time 0.
Oh, because it wasn't there because you were at time 0.
Yeah, so this is the time 0 equation of value. This is the time tau equals 1 equation of value. So when I bring the 2,000 to time 1, I forecast it by multiplying by 1 plus I. Right? Similarly, this P only got brought back 2 places. Here, the P got discounted 3 places.
Okay.
You follow?
Yeah, that makes more sense.
Okay. Yes, babe.
Could you have picked like tau to be 3?
Yeah.
Okay, so anything works.
Any tau would work. Any tau at all. Even tau equals 5 would work. Even though everything is over by time 3. Okay? So this is crucial later as things get crazier. Okay. So next problem. Example similar to 2.3.6 from text. The following deposits are made into a savings account with compound interest I. 5,000 at t equals 0. Let's do it. 0, 5,000. Timeline is crucial. 3,000 at t equals 2. 2,000 at t equals 3. At t equals 3, just after the 2,000 deposit, the balance is 12,000. So let's write here balance equals 12,000. Calculate I. Let's do the time 3 equation of value. Why not? Right? That would be a good choice. So time tau equals 3 equation of value. Anything would be okay for tau, but 3 makes the most sense. So 5,000 times 1 plus I cubed, because I'm forecasting 3 places, plus 3,000, 1 plus I to the 1, forecasting one year, plus 2,000 equals 12,000. And solve for I. So we let x equal 1 plus I. Let x equals 1 plus I. So then I would have a cubic. So this would be 5,000 x cubed plus 3,000 x minus 10,000 equals 0. So if you could go to your calculator and put it in this y equals.
Could you move the calculator to the right a little? Yeah.
Isn't that worse?
Yes. All right, never mind then.
I think this is the best view I can give you on the calculator. Right? Because if I move it into the light, you won't see it properly. Okay, so y equals, let's go put it in. 5,000 x cubed plus 3,000x minus 10,000. And then calculate. So second, first I might want to fix my window. So how about window from 0 to 2. Notice x is 1 plus I, right? So I'll pick it from 0 to 2 by 1. and I think the rest is okay. So how about second, calculate 0. Did I color it? Did I choose it? Yeah, it's chosen. Okay, second, calculate 0. Left bound 1, right bound 2, guess 2, that's okay. So it gives me the 0. So it says calculator, let me just write my steps here. Calculator, y equals, put in the equation, and second, calc 0, where the left bound is 1 and the right bound was 2 and the guess was 2, and it gave me a 0. X equals 1 plus I, in my case, is equal to 1.1021. So my I is 0.1021. Everybody okay? So this you would be expected to do, so make sure that you have a calculator that can do that. Any question? Any question? Yes?
How do you get the left one right too?
So it gave me two guesses. So look at this, okay? I'm looking for x, which is 1 plus I. So if I is 0, this would be 1. So my left guess I put in as 1. And if I is 1, which is 100%, then my right guess would be 1 plus 1, which is 2. So I figured that that window would cover everything.
Okay.
Get it? Next page. This is example 2.3.7, the same one from the text. Most of the examples will be a little bit different than your text so that you can go and practice on the text problem. So for example, on the previous page, it says similar to 2.3.6, similar to 2.3.5, but it's not the same, so that you can go practice on those. This one happens to be the same. 2.3.7 from text. It says Franklin borrows 1,000 at t equals 0. Let's draw a timeline. Borrows, so it's positive for him, right? Because the money is coming in for him. With compound interest 10%, he will repay the loan with 2 equally spaced payments of $525. When are the 2 payments made? So let's call this time t, because I don't know when. And he's going to make a payment of $525. And at time 2t, he's going to make another payment of $525. How about time 0 equation of value? Tau is 0. Let's bring everything back to 0. What will it be? Can you tell me? 1,000. Minus 525. So shall I divide? Can I divide? 1.1, because 10% interest, right? 1 plus I to the t. Minus 525 1.1 to the 2t divided by 1.1 to the 2t equals 0. Okay. Then let's put everything over 1.1 to the 2t. So 1,000, 1.1 to the 2t minus 525, 1.1 to the t minus 525 equals 0. Let 1.1 to the t be x. So 1,000 x squared minus 525 x minus 525 equals 0. So quadratic formula, x equals minus b plus or minus square root of b squared. It's negative, but I don't care because the negative will be gone. Minus 4ac all over 2a. Okay, we're good. So x equals 525 plus or minus, let's do this. $525 squared plus 4,000 times 525. 2375625. And I want the square root of that. 1541.306. 1541.306 divided by 2,000. So I'm going to get two roots. $1.03315 and 525 minus 1541.306 divided by 2,000. Negative 0.508. So x is 1.1 to the t power. That can never be negative for positive t. So reject this one. Reject because 1.1 to the t cannot be negative for positive t. So that's rejected, and my t equals, this is 1.1 to the t equals x, so 1.03315. Let's take the ln of both sides. T ln of 1.1 equals ln of 1.03315. So t equals ln of 1.03315 divided by ln 1.1. 0.342. T equals 0.34. That's my answer. 0.34 years. And 2t equals 0.68 years. Those are the two times when the deposits, when the payments were made. Everybody get it? So you have to become pretty adept with your calculator, because on an exam not going to have time to mess around. You're going to have to practice with practice these problems with the calculator. Let's do the next one. Method of equated time approximation. Given the cash flows C1, C2, Cn at times T1, T2, ... Tn, let capital C be the sum of all the contributions Cj. We would like to find a time such that the lump sum of C invested at time T is equivalent to the previous cash flow. Do you understand the question? Let me give you a quick example so you see where we're headed, okay? Let's say that at time 1 you have a contribution of 200, and at time 4 you have a contribution of 300, and at time 5 you have a contribution of 500. First thing you do is add these. So 500, 800, plus 200 is 1,000. So sigma C is $1,000. 1,000 equals summation of the contributions. So the question here is, can you find a time T where 1,000 at time T is equivalent to all this cash flow? That's the question. Follow me? So let's see. Can I tell you the punch? Can I tell you the punchline? The punchline is going to be this: 200 times 1 plus 300 times 4 plus 500 times 5 divided by 1,000 is going to give you the approximation for T. Let's call it T bar. That's going to be the punch, meaning you don't have to go through all the V of T business that we normally do. The approximation says that you can take every contribution and times it by the time when the contribution was made and set it equal to T times the total contribution. Are you with me? So what would we get here? We would get 200 plus 1,200 plus 2,500 divided by 1,000. So 37 plus 2, 3,900 divided by 1,000. Catch my mistakes if there are, equals 3.9. So I claim that 1,000 at time 3.9, roughly speaking, this is an approximation, is equivalent to all these different contributions at all the different times. Are you following me? That's where I'm headed, okay? I have to prove it to you, but that's where I'm headed. So let's put this in here. I didn't know where to draw it exactly, so I didn't draw the T right yet. So this is saying that 1,000 at T equals 3.9, where 1,000 is the sum of the contributions, is equivalent to all these different contributions at all these different times, roughly speaking. This is roughly speaking. That's my T bar. Okay? Any question? Any question? So let's go see how we do this. So first of all, C, that's the total contribution, is C1 plus C2 plus ... Cn. And let me draw a timeline. So at T1 I have C1, and at T2 I have C2, and at Tn I have Cn. And then at some time T, which of course I'm looking for. I have C, which is summation of Ci or Cj, whatever we called it before. This is times 0. So I can write an equation, right? My equation is the following. C, this C right here, let's discount it. I want to write a times 0 equation of value. Discount C times V to the T equals C1 V to the T1 plus C2 V to the T2 plus dot 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 Cn V to the Tn. Why don't I just write that as summation Cj V to the Tj? Summation on J, right? J equals 1 to n. So when I take this and this, I can solve for V to the T. After all, I'm after T, right? That's what my goal is, to find T. So V to the T equals summation J equals 1 to n Cj V to the Tj divided by C. Let's take the ln of both sides. So T ln V equals the ln of this mess right here. Summation J equals 1 to n of Cj V to the Tj divided by C. And I better go like that. So T equals ln of the mess divided by ln V, where the mess is summation Cj V to the Tj over C. So this is complicated. This is a complicated mess. So we want to come up with an approximation. Complicated. So we need to approximate T. So I will find an approximation. And for this approximation, I will use the binomial expansion. Use the binomial expansion. One plus x to the minus n power is equal to 1 minus nx plus n plus 1 over 2 factorial x squared minus n plus 1 n plus 2 over 3 factorial x cubed, blah, 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 blah. So I will use the first 2 terms of the binomial expansion, this one right here. Oh, I'm sorry. So the first order binomial expansion, first order binomial expansion of 1 plus I to the minus t power, because I have v to the t everywhere, right? So that's the same as 1 plus I to the minus t. So let's label that v to the t. 1 plus I to the minus t is equal to, and I'm using this right here, 1 minus I t. So I have cv to the t equals sigma cj v to the tj equals sigma, let me write them both in terms of 1 plus I. So c 1 plus I to the minus t equals sigma cj 1 plus I to the minus tj. So by the binomial expansion, I have c 1 minus it equals summation cj 1 minus itj. Using that same rule on both sides, and then I clean this up. So this will be c minus cit equals summation cj times 1 minus I summation cj tj. This c and this summation cj cancel because c is equal to the sum of all the contributions. So I'm left with t equals minus I summation cj tj over minus ic. I and I cancel, and I'm left with summation cj tj over c. Where c is equal to sum of the contributions cj, j equals 1 to n. And that's the rule that I used before. So it's saying you don't have to do all this crapola. Just take every contribution, multiply by its time, and divide by the sum of all the contributions. That will give you an approximation for t. Get it? So I want to do the following example both ways so that we can see how far we are from the approximation. It says payments of 300, 100, and 200 are due at the ends of years 1, 3, and 5. Let's do it. Timeline. At the end of year 1, I have 300. At the end of time 3, I have 100. And at the end of time 5, I have 200. Assume 5% annual effective interest rate. Find a point in time at which a payment of 600 would be equivalent. So notice that 600 is equal to summation Cj, right? Because 300 plus 100 plus 200 is 600. So it's saying find the point in time. So the real way to do this with the exact answer, so let's write here exact answer. $600. So the 600 is somewhere here, but I don't know where, right? V to the t is equal to 300 v to the 1 plus 100 v to the 3 plus 200 v to the 5 is equal to 300 over 1.05 plus 100, what mistake?
Oh no, I was just trying to see what you had on the left. Yeah, thanks.
Exact answer, it says. plus 100 over 1.05 cubed plus 200 over 1.05 to the 5th power. So this gives me 528.80328, and therefore v to the t is equal to 528.80328 divided by 600, which is 0.88133. 0.8813388. And I'm looking for t, don't forget. You see that this is a pane, right? V 1.05 to the minus t, that's v to the t, equals 0.8813388. Let's take ln of both sides. So ln of 0.8813388 is equal to minus t ln of 1.05. So ln of answer divided by ln of 1.05 equals, and this guy's negative and this guy's negative, so t equals 2.5889. That's what I got. T equals 2.5889. That's the exact answer. Everybody good? It's doable, it's just a pain. Now let's do it by approximation. So let's just look at the timeline here. C times t bar is equal to every c times its time. So 300 times 1 plus 100 times 3 plus 200 times 5. And my c is the sum of these, which is 600. So t bar equals 300 plus 300 plus 1,000 divided by c, which is 600. So what do we get? 1,600 divided by 600, is that correct? Equals 2 points, give me 1 minute, 1,600 divided by 600. 2.6 repeating. Done. Right, so that took like a minute. That's the approximation. Very close. This one is 2.6. This one's 2.66. Now notice that this one was independent of I. Nowhere did we use I. Imagine. So this approximation works no matter what I is. So let's write that. Totally independent approximation is totally independent of any interest rate. In fact, there's some theorem we are not going to prove it, but we can state without proof. Let's state without proof that the approximation is always greater than the exact answer. And so this is called weighted average time. weighted average time. Method of equated time or weighted average time. Everybody good? I guess this is where we end.